Okay, dear students, physics class 1, new chapter, transient of circuits. The meaning of transient of circuits means the circuit which stores charges or current for a very short interval of time. That circuits are known as transient of circuits. So in this theory, the theory of charging and discharging of capacitor through the resistance we are going to study. Okay, theory of charging of capacitor. Dear students, charging and discharging of capacitor is already you studied in PUC Science second year, but still we study here also. So you can see the circuit diagram for charging and discharging of capacitor. So capacitor is connected in series with the resistance and the battery. So these are O, P, Q are the plug-ins. When we connect O, Q, then the capacitor starts charging, and when we connect OP, the capacitor starts discharging. Okay, so let Q be the charge on the plates of the capacitor, I be the current in the circuit at that time, and E be the EMF of the battery. Consider a circuit containing capacitor and resistance in series with the battery. When the point O and Q are connected, the capacitor starts getting charged. Therefore, potential difference across resistance is equal to I into R. V is equal to IR. We are just applying the Ohm's law here. And potential difference across the capacitor is equal to Q divided by C, because C, capacitance of the capacitor, is equal to Q, that is the charge on the plates of the capacitor per unit voltage. So therefore potential difference across capacitor is equal to Q divided by C. The total potential difference across the circuit, here the total potential difference across the circuit is equal to potential difference, sum of the potential difference of capacitor and across the resistor. So therefore it is equal to IR plus Q divided by C. According to Kirchhoff's second law, the EMF applied to the circuit is equal to the sum of the EMF across the different components. So therefore, E is equal to applied EMF, that it is equal to EMF across the resistance plus EMF across the capacitor. But I is equal to rate of change of flow of charge. So therefore, I is equal to dq divided by dt, where q is the charge for a time interval t. So substitute this in the above equation, and E divided by R is equal to dq divided by dt plus q divided by R into C. We just divided the equation by R here. So therefore just rearrange the terms. dq divided by dt is equal to E divided by R minus q divided by RC. So take common 1 by R. So what remained in the bracket? E minus q divided by C. Okay. So rearrange the terms here. dq divided by E minus q by C is equal to dt divided by R. Just take a cross. dt on this side and q remains there in position. So therefore E minus q by C, it comes denominator of the dq divided by, and dt goes numerator and remains what? 1 by R there. Okay, call this equation number 1. Now integrate equation 1 with respect to q. We get integration of this thing is equal to 1 by x, integration is log x. So that thing here, so log of E minus q by C. So we are integrating with respect to q. So therefore with respect to q it is equal to minus 1 by C, and it is equal to dt divided by R. Integration is t by R plus a, where a is an integration constant. When t is equal to 0, q is equal to 0. In the sense, initially before charging the capacitor, charge across the capacitor is equal to 0. So that time is 0 we take, then the charge across the capacitor is 0. So therefore equation 2 reduces to minus C log E is equal to A, because Q is equal to 0. So this term becomes 0. Okay, so T becomes equal to 0, this term becomes equal to 0. So therefore this minus 1 by C when comes to numerator, minus C log E is equal to A. Substitute this in equation 2. So therefore minus C log of E minus Q by C is equal to T by R minus C log E. We just substituted the value of A in this equation, and this 1 by minus 1 by C comes numerator. So therefore it is equal to minus C log. So now redistribute the terms. C log E minus C log of E minus Q by C is equal to T by R. Just take this term to left side. So take a C common. So log E minus log of E minus Q by C is equal to T by R. So therefore log E minus log of E minus Q by C is equal to T by RC. Just take C to right side, it comes denominator. So therefore log of E divided by E minus Q by C is equal to T divided by RC here. Log A minus log B is equal to log of A divided by B. That relation we used here. Therefore log E minus log of E minus Q by C is equal to T divided by RC. So therefore log of E by E minus Q by C is equal to T divided by RC. So we take logarithm out. So what remains, E by E minus Q by C is equal to this term reaches to E to the power of T divided by RC. So just reciprocal this. So E minus Q by C divided by E is equal to E raised to minus of T divided by RC, or 1 minus Q divided by EC is equal to E raised to minus T divided by RC. So rearrange the terms. Q by EC is equal to, take this 1 to the right side, 1 minus E raised to minus T divided by RC. Now put EC is equal to Q naught, that it is the maximum or steady charge on the capacitor after charging fully. When the capacitor gets fully charged, then Q naught be the charge on the capacitor. So therefore it becomes Q by Q naught is equal to 1 minus E raised to minus T divided by RC. Okay. So therefore Q is equal to Q naught into bracket 1 minus E raised to minus T divided by RC. Therefore charge on the plates of the capacitor increases exponentially with time. When we draw the graph of Q versus T, the exponential increase in graph we found. Okay, when we draw the graph of charge versus time, we obtain exponentially increasing charge through the capacitor. Okay, so now Q naught be the maximum steady charge stored in the capacitor. Then when OD is equal to 0.63 into Q naught, that is OA becomes the time constant of the, that is RC circuit. Okay. Therefore time constant for RC circuit, let T is equal to RC, substitute R into C. Therefore Q is equal to Q naught into bracket 1 minus E raised to minus T by RC. Substitute the value of T is equal to R into C here. So Q is equal to Q naught into bracket 1 minus E raised to minus 1. RC get cancelled, it remains minus 1. So therefore it is equal to Q is equal to Q naught into bracket 1 minus 1 divided by E. So therefore Q is equal to 0.63 into Q naught, where E value is 2.718. So therefore, definition of time constant is the time during which the charge on the plates of the capacitor becomes equal to 0.63 times of steady charge, that is Q naught, is called the time constant of RC circuit. So it is equal to the product of capacity in farad and resistance in ohm. So therefore, time constant T is equal to R dot C in seconds. Okay, dear students, next point, theory of discharging of capacitor. So in this case, the circuit diagram is same. In charging, we close O and P, and in discharging, initially we close O and P to fully charge the capacitor, and then after we open the O and P and then close O and Q, then the capacitor gradually discharges through the resistance R. Okay, let Q naught be the steady charge on the plates after fully charged. Q be the charge on the plates of the capacitor after the time interval t second. I be the current in the circuit at that time, and E be the EMF of the battery. Consider a circuit containing a capacitor and resistor in series with the battery. When the point O and P are joined, the capacitor starts getting discharged. Okay, since I is equal to, that is the current rate of flow of charge, so therefore dq divided by dt, and the potential difference across the resistor is IR again, and potential difference across the capacitor, it is equal to Q by C only. So therefore total potential difference across the circuit is equal to I dot R plus Q divided by C. We just substitute the value of I is equal to dq by dt into R plus Q divided by C. During discharging, applied EMF is 0 in the sense, so while discharging the capacitor, the applied EMF by this battery is 0 because we have disconnected OQ here, we connected OP here. Okay, so therefore from the Kirchhoff's law, dq divided by dt into R plus Q by C is equal to 0 because applied EMF is 0. So dq divided by dt into R is equal to minus Q by C. dq by dt is equal to Q divided by RC. dq by Q is equal to minus dt by RC. Okay, so integrating equation 1 on both sides. Okay, so therefore 1 by dq divided by Q, that is log Q, is equal to dt by R dot C, integration is minus T divided by R into C, plus A is the integration constant. When T is equal to 0, Q is equal to Q naught. What does it mean? When initially the capacitor is fully charged first, and then before discharging we take that time as a 0 time, and when we start discharging, so we count the time. Okay, so therefore before discharging plug is closed, that time the charge on the plates of the capacitor is equal to Q naught. So therefore substitute these two values in equation 2, we get log Q naught. Q is equal to Q naught log Q naught. So as T is equal to 0, this term gets 0, so it is equal to A. So therefore equation 2 becomes log Q is equal to minus T divided by RC plus log Q naught. Just take log Q naught to left hand side. Log Q minus log Q naught is equal to minus T divided by RC. Therefore log A minus log B is equal to log of A divided by B. That relation we have applied here, and it is equal to minus T divided by RC. Or Q divided by Q naught is equal to E raised to minus T divided by RC. When we remove the log, it becomes exponential. So therefore, Q is equal to Q naught e raised to minus t divided by RC. So charge on the plates of the capacitor decreases exponentially with time. From this term we came to know. Okay. Now, when we draw a graph of, that is, applied discharging along y-axis and time along x-axis, then the obtained graph is exponentially decreasing voltage across the capacitor we found. Okay, so now the maximum steady charge on the capacitor is Q naught. When it is multiplied with the 0.37, then we get OD. Here OD, we cut that OD across here and we get OA as the time constant. That is, time constant is equal to OA into seconds. Okay, so time constant of RC circuit. We know Q is equal to Q naught e raised to minus t divided by RC. Put t is equal to R into C. So therefore Q is equal to Q naught e raised to minus 1. So e raised to minus 1 means 1 by E. So 1 by E value, substitute the value of E here. So therefore Q is equal to 0.37 into Q naught. So the time during which the charge on the plates of the capacitor, the time during which the charge on the plates of the capacitor falls to 0.37 times the initial steady value or steady charge. So therefore, the time constant of RC circuit is equal to the product of capacity in farad and resistance in ohm. So therefore, time constant T is equal to R cross C in seconds. Okay. Thank you, students.